Hello, and welcome to the last section of probability and stats. This one's on z-scores. If you're at home, you cannot do the last part because you don't have the right calculator to do so. So unless we're in school, we will not do that next section, so you won't do that part of the homework or that part of the test. So I hope you have your z-scores ready. You should be on your note page. I will also warn you I'm using a new program and it's not quite liking me the whole time. So we'll see how it goes. Here we go. All right, so we're talking about z-scores today. And when you're looking at your z-score, the z-score is how far away from the mean you are. All right, so z-score is a value that shows how many standard deviations hopefully this writes, there we go. Deviations, a data value is from the mean. Remember, mean is represented by mu, and standard deviations is actually a lowercase sigma. Now, a z-score is positive, the data value is above the mean. So if you're positive, you're above the mean, that's an O. And if you're negative, you're below the mean. So your z-score tells you if you are above or below average. If you are equal to 0, or if the z-score equals 0, you are actually average. You are the mean. Okay, so to find the z-score is equal to your number, or your value, minus the average, or mu, divided by the standard deviation. All right, let's give a few examples here. A radar detects or records the speed of a group of cars that pass by. Now, if the mean is 46, so right now I know that mu is 46, and the standard deviation, so sigma, is 2.8. Find the z-scores for each data value, so I'm finding z. So all you're doing is plug it into this formula. So I know my z-score is equal to 52, my number, or my speed, minus the average speed, divided by 2.8. And when you get that, you should get 2.14. That means you are 2 standard deviations above the mean, so you're going actually very fast. Okay, pause and try yours. So this one here, your z-score was 42 minus 46 divided by your 2.18, and you should have gotten a negative 1.43. So you're almost 1.5 standard deviations below the mean. You're going too slow. Next one, you should have said 47 minus 46 divided by 2.8, and you would have gotten 0.36. That means you are doing very well. You're driving where you're supposed to. You're within 1 standard deviation of the mean. Okay, I want you to pause and try yours and see if you can figure out what it's telling you. Okay, now when you're reading, the mean number of total miles ran last week by each member of the track was 4. So they gave you 4, which is the mean. So you know you have the mean equals 4. You know your standard deviation is 1.2. But this time they said Clay's z-score was 2.5. So the z was equal to 2.5, which means you want to find x. So when you plug this in, you went 2.5, because that's your z-score, is equal to how fast is he, or how far did he actually run, minus 4 divided by 1.2. I'm hoping you remember how to solve, so you need a common denominator, right? So we multiply 1.2 on each side, and that canceled, and you should have gotten 3 equals x minus 4. So x is 7. He ran 7 miles. Because he's way above the mean, right? The 2.5 says he's 2.5 standard deviations of mean, so he ran along a lot more than the other ones. Okay, try this one if you didn't do well in that one. Standard deviation of 5, so we know sigma is 5. Riley scored 83, so that's X is 83. He's got a z-score, a negative 0.4. I'm asking you to find the mean this time. So I can ask you to find any one of those variables. And that's all it's doing. Do you remember how to do your math? So we do a negative 0.4 equals 83 minus mu all over 5. So this time we're going to multiply by 5 to get our common denominator, which is going to give us, I'm out of room here, negative 2 can equal 83 minus your mu, subtract your 83. So your average is equal to 85, negative 85, negative mu. So mu is equal to 85. All right, I think you got this. So we're going to go on to the next one. And this is where I wanted to show you what you cannot do, unfortunately. So when we go here, this is the part you actually need a calculator for. So you know a normal distribution in which mu equals 0 and your standard deviation equals 1. All right. When that happens, you get the standard z-score. And that's when we use our calculator. And we don't even use this one. We have a different one that I like to use. But you'll plug in the z-scores for one side, and it's called the normal CDF. So if you have a calculator that does normal CDF, you're welcome to try this. But you'll plug in lower bounds, upper bounds, mu, and this, and it will give you the answer, which is absolutely awesome. So if you have one, I could not find one online that did it well. If you have one or you find one, let me know, and we'll go through that. Okay, so that means on your homework, I only want you to do this first page right here. I do not want you to do this section, which requires this. So this is what you are not doing. Okay, and then after that, this is your formula sheet. You may use this on the test. So fill this in, put your formulas over, an example if you would like. And then this year is just a practice. It's not actually your test. So you're welcome to practice that. Okay, good luck. I hope you did well. And we'll work on our review next.